Hello and welcome. My name is Faisal from Phoenix Academy. On this tutorial, I'm going to walk you through the steps of creating a Python script that could be used to scan a network. So it basically works like a network scanner. So we are going to make use of our programming skills to create a tool that we could use to scan the network, to discover hosts on the network. This is Ficham in Linux machine, and I've already created a project called network scanner.py. So we are going to start coding immediately. So this first line of code is what we call a shebang. Now shebang tells the computer the location where we have the Python interpreter that we intend to use to run this particular script. And this Python interpreter will be found within this directory user bin in Python 2. So Python 2, even though we might have Python 3 in this same machine, but Python 2 is going to be used to run this script that we are going to create. Alright. Now the first thing we do, we are going to import the modules that we are going to use in this particular script. Now among these modules, we are going to import scapy.all as scapy. Now I've imported a module called scapy.all and I want to use it as scapy, so I basically rename it as scapy. So whenever I will reference it throughout the program as scapy. Okay, and then I'll import another module, import argfast. So I have imported another module called argfast, which will be used in passing over the command line. Okay, so we are going to see how we use these modules over the program. Okay, so the next thing we do now, we are going to create a function, and we know the rationale behind creating a function. A function is just a unit of a program performing some some work which contribute toward the overall objective of creating the whole program. So the whole bulk of the program is divided into units called functions. So the first function we are going to create is getIP. Okay, so we know def is a keyword that declares a function, and the name of my function is getIP. So this getIP does not need any parameter, so we didn't declare any parameter to go along with this function getIP. So whenever I call this function, I don't need to supply any argument whenever I call this function. Okay, okay, so what I did in line number 9, I created an object instantiation. This is what we call an object instantiation. So I have created an object of class argument parser from module, and this class argument parser is from the module argfast. And so the name of my object now is parser. So basically in line 9, I'm creating an object called parser, an object of class argument parser. Okay, so let's proceed. Sorry, that's a dot. Range of IP addresses. Okay, so line number 9, I'm adding an option to my object for parser. So basically what parser does is that it's going to pass over the command line. So I expect that the user of this program is going to supply the IP address over the command line. So now it is the this parser object will now pass over the command line and then get the IP address from the command line that the user of this program is going to input. So so this user of this program is going to input this particular IP address using the argument target. Okay, using either the t switch or -- target, and then whatsoever the value the user enters is going to be stored in the variable dest IP address. Okay, dest equals to IP address, so the value is going to be stored in variable IP address. Okay, then this help is the help option, is the help message that will be that will be issued to the user of this program when he type the name of the program and then write help. Then this help is going to be printed out. Okay, so let's proceed. Options equals to parser plus first ax. So now this particular line number 11, first ax is a function. Of object parser. So this function will pass over the command line, then get the input that the user is going to input over the command line, and then it's going to store it in variable options. So the IP address that the user inputted is going to be stored in variable options. Okay, specify an IP address for a range IP address. For more info. Okay, so line number 13, we are using a if selection control structure. So to determine whether the user actually inputted the value of the IP address or not. So if the user of the program does not input the value of the IP address, so line number 13 is going to evaluate the false, and therefore this error message using error function from the class argument parser is going to be output this particular message, informing him to specify an IP address or a range of IP address and or to type help for more information. Okay, so we are finally done with this option. Now the next thing is we return options. So finally this particular function will return options. Remember that options is going to have the value of the IP address from line number 11 that the user will eventually input it. Okay, so let's define another function again. Def scan IP. Okay, so function scan IP will be responsible for doing the actual scanning. Okay, so let's see how we go about creating it. ARP header equals to skp dot arp test equals to IP. Okay, so line number 19, I created a ARP packet. So ARP class. So I created an ARP header is basically an object I created from the ARP class, and this ARP class is from the module Skiffy. So the role of this particular object will be to issue out the ARP request. Who has IP address? Who has this so-so IP address? So it will go over the whole of the network, the subnet IP addresses, asking for their MAC addresses. So asking who has IP address, we know how the ARP protocol works. So it is going to ask who has this so-so IP address, who has this so-so IP address from the first IP address of the subnet up to the last IP address within that particular subnet. Or if the user of this program just issue one IP address, so it will just make use of that IP address. So we can see that this particular ARP class has a field variable called pdest, and we have initialized the value of pdest with the IP. So an IP is a parameter that will be supplied as argument whenever we call this function scan. So whenever we call function scan, we are going to supply an argument to it, and that argument is actually the IP address. So that IP address is going to be initialized to field variable pdest of ARP class. Okay. Next, we create another packet, the ETA packet. Okay. ETA. Okay, so what I do in line number 20, I basically created another packet called the ETA header, which is actually an object of class ETA, which is from the module Skiffy, and I've initialized the dest field variable, and I initialized it with the broadcast MAC address. So actually I've specified the destination that this particular packet is going to be transmitted not only one IP address, but it's going to be transmitted as a broadcast packet. So all the hosts on that particular subnet will receive a copy of this particular packet. So I've specified the dest is usually the destination address. So this FF is means the broadcast MAC address. So that means we know that MAC address is the address used in communication over a network. So within the network, within the subnet, MAC address is used by host to communicate among themselves. Okay. So let me create another variable, ARP request packet. Okay, so in line number 21, I basically joined the two packets, the ARP header and the ETA header, to create one single packet, which will be responsible for sending the ARP request to all the hosts on the network. So this is a complete now. ARP will actually perform the ARP request. So it will go over all the hosts on the network, asking for their IP addresses. Okay. Okay, so in line number 23, I make use of a srf function from the class KP. Now this srf function is actually responsible for now relaying the ARP request packets to all the nodes. It will actually be the one to transport the whole of the ARP request packet, which is the ARP request. It will be responsible for transporting it to all the nodes in the subnet, since we have specified the MAC address as the broadcast MAC address in line number 20. So it will relay this our ARP request packet to all the machines on the subnet, asking for their MAC address. Okay, now answered list, and we have this the zero. This zero will be responsible for ensuring that actually what happened is that this srf function will return two values to us, two lists actually. When you go to the documentation of the srf function, you see that it returns two lists. Now the first list is a couple, which contains answered packet sent, which is the packet that we sent, ARP request packet, and then the answer received. So we are going to send it will contain a couple. The first list will contain a couple, the packet sent, which is the ARP request packet, and then the response that we receive from the station, those that responded. Okay, while the other list will contain the unanswered packets. Okay, and those stations that were not off and couldn't respond. Okay, so now we specify that all that we want the first list. That is why we write this within this square bracket 0, index 0. So we are specifying that we only want the first list, which is that couple that contains the packet transmitted and then the answer received. Okay, and this will be assigned to variable answered list. That is why we even name it answered list. Okay, client list. So line number 25, we initialize an empty list called client lists, and we are going to see how we go about using it. So for elements in So actually line number 27, I created a dictionary. A dictionary is another data structure available in Python. So we have it looks similar to list, only that we don't use an index to reference the element within a dictionary. We use what we call a key and a value pair. So within this, I have two elements. The first element is IP with key IP, and then the value is element1.psrc. Okay, what does this mean? It means that we will line number 26, we are trying to iterate through elements in answered list. So we are trying to go through, we use for loop, for control structure, for looping control structure to iterate through the answered list. Remember that answered list is a list that contains couples, packet sent, and then the answer received. So we want to iterate through it. So for the first time, element will contain the element of the answered list, which is actually a couple. Remember a packet sent, and then the answer that we receive. Okay, so now client dict, we in line number 27 we created a dictionary called client dict, and we initialize it with this element. The first element is IP, key IP, and then the value is element1.psrc. So element1 will refer to the answer received of the first element in answered list, not the packet sent. So the answer received packet of element1. That's why we write index 1 element1. Now psrc will refer to the IP address of the source. IP address of the source that sent us that particular response. Then we have mark, a key mark, and then the value is element1.hwsrc. hwsrc refers to mark address of the source. So the element1 refers to element index 1, refer to the answer that we receive, the answered packet that we receive, and then we are referencing its mark address, hwsrc. That is what it refers to. It refers to the MAC address of the source that sent us that particular response. Okay. Okay, so eventually in line number 28, what we are doing, we are using the append method of list. List has a method called append, and append, actually what append function actually does is that it adds an element to a list. So we are adding client dict from line number 27 to the empty list we initialize in line 25. So it's going to add that particular dictionary to our client list in line number 25. So actually client list is a list whose elements are actually dictionaries. Okay, so line number 29, we are going to return the client lists. So any line of code that calls this function scan IP is going to receive this particular dictionary list of dictionary client lists. Okay, so let's proceed. Now next we are going to create another function again, def print result. Now it requires a parameter. We are going to declare it with a parameter called result list. Okay, so we created a function called print result, and it's going to have a parameter called result list. So any function, any line of code calling this particular function will actually supply an argument that is going to be initialized this parameter result list. Okay, so what do we do next? Let's print Okay, so what I'm doing in line number 3, I'm trying to print out a header. Just actually we say we want to have a program that works exactly like netdiscover. So it's going to print out a header where we're going to have IP, MAC, and then all the IP addresses are going to be placed under the IP section, and then all the MAC addresses are going to be under the MAC section. Okay, so basically that is what line number 3 is doing, just printing out a header. And we are using the escape sequence, /t, which will give us one complete tab stop, one complete tab, and then we are using three tabs, while the /n is called the new line character, which will print out this dash lines in the next new line. Okay, so line number 34, I'm trying to iterate through the result list. Okay, we are going to supply the result list, which is the list that we are going to. This function actually required, we are going to input to it as argument the result list. So line number 32 is going to iterate through the result list, and then going to print it out in line number 35. So let's see how we go about doing that. Client Okay, I think 2 would be enough. So client IP. Okay, actually I made a little error here. The IP and client MAC. Okay, so it's going to iterate, and then it's going to print out the dictionary elements using their keys. It's going to print client IP will actually refer to IP address, because IP is a key whose value is an IP address. Likewise, MAC is also a key whose value is a MAC address. So it's going to print out the IP and then give us 2 tab stops and then print out the MAC address. Okay, so far these are the 3 functions where we need to create this particular network scanner. Now let's go to the main body of the program where we call these functions and see how they work. Okay, so I say IP equals to get IP. So in line number 38, I'm calling function get IP. And remember, the function get IP does not require any parameter, so that I call it straight ahead, and then whatsoever value it returns is going to be assigned to this variable IP. Okay, and what does get IP is going to return options, which option contain the IP address that is going to be inputted by the user. Scan result. Okay, so line number 39, I'm calling function scan, and I supply to it IP address as the argument. Now remember that IP is going to return IP in line number 38 contain actually options, which is returned by the user of this particular function get IP. Now, so IP is going to contain both the argument and the value of the argument. Is going to contain both the target, this particular variable target, as well as the IP address imported by the user. Okay. Now we reference to its car result as car result shall IP address. So we are only inputting IP address as the input to function scan. So therefore, car result is going to contain the value of the actual IP address as the value. So car result. So we are inputting IP address. We are inputting IP address to function scan, and whatsoever the value function scan return is going to be assigned to scan result variable. Okay. So now we call the next function print result. So line number 40, I'm calling function print result, and I'm supplying to it scan result as the input. Okay, so remember that function scan is going to return the client list, which is a list of dictionaries. So print result will actually contain results. There's a typo here, result. So it's going to actually contain list of dictionary, which is going to iterate through and then print it out for us. Okay. So let's go ahead and run this program and see how it works. IP address, test IP address. I can't find any error here. Okay. What is he saying? Show us in the IP autoscope. Okay. Let's run this program and see how it works. So we just go to the command line, your terminal. Okay, let me increase the length a little. Okay, so I'm going to go to the navigate directory where I have this, where I created my project. Desktop, Python. Okay, ls network scanner. So cd network scanner. ls. Okay, so clear Python 2 scanner.py. Let me just scanner.py, and I supply the target 92.168.43.1 clear 24. So I just press enter. So actually it has performed it has finished scanning, and it has returned the result, and this is exactly what we're expecting. Okay, So only that we can remove this begin emission finish sending to 56 packet. We can do away with it on the program. Then how do you go about it? We can go there and make verbosity equals to false. Go to function scan where we have this function scan. Okay, SRV timeout equals to 1 and then verbose equals to false. Okay, so we can verbose equals to false. Okay, then we save, go over again, run the program and see how it works. Okay, so I run it again. That's how it works. Okay, so it works perfectly all right, and it has given us the result that we need. Okay, so this marks the end of this tutorial. Thanks for listening. You can get the blog post on this particular tutorial in the Phoenix Academy. Go to the blog section and you can learn more about me about when going to the about me section. Thank you for listening. Thank you.